Hello. Can everybody hear me? Maybe not. Let me fix my microphone situation here. Okay. I have the shittiest microphone stand. It's really bad. The people in the chat, can you tell me if the audio is okay? I messed around with it yesterday night. There is 2 people in the chat. Amazeballs. So I think I'm gonna pop out this thing. No. Just as a secondary source of information. It seems the chat in Twitch is not really real time and doesn't update so well. Who likes me on Twitter for my fake internet points? Oh, cool. So I think I'll give this another 5 minutes or so before I start talking. Hey Igor. Yeah, I'll give this another 5 minutes before I start talking about what I wanted to talk, because I got a couple of people. It's not nice looking, but it works. I got a couple of people that told me they would join the stream, because this is a post-mortem. So I'm not gonna do any programming. I'm just gonna do some talking, hopefully with some feedback from you guys in the chat. It would be very nice to get more interaction with you. Otherwise it feels like I'm screaming into the void, which is cool, which I'm used to, but now I changed my, what the hell. Yeah, anyways. So I'm also gonna use this opportunity of this last stream in a while to write a post-mortem outline, because I am going to convert this stream post-mortem into a blog post that discusses the individual things I wanted to discuss. Yeah, that's what I'm gonna talk about today. But again, I want to wait for a couple of people, so I'm giving it another 5 minutes until 6:15 for those people to join, because I want them to hear it from the beginning. It's so weird. Like, Igor, you're not on the... See, there's the chat. And if I look at the people in here, it doesn't show you. So this is a part of Twitch which is kind of sort of annoying, because I don't know who's actually here and who isn't. I got a second chat client which shows me that you're here, but yeah, I don't know. So while I talk, I'm gonna oh, my microphone just went away. While I'm talking, I will put down what I'm talking about in here. So while we wait for the people, let me just write down what I'm gonna talk about. So the first thing I want to talk about is my motivation for building Paperbots, and this is gonna take you through what I'm actually doing in real life outside of this internet business, and how I came to work on something in the educational space. Then I want to talk about Paperbots, the paper version, and how that worked out. And then I want to talk about 7 Days of Madness, which is the digital version, which you can see here. Again, maybe while we wait, I'm going to just show you how this works now. So you got the editor, the playground, the world, whatever you want to call it over here. And you can place and rotate your robot like you want to. Then you can build walls. not the Trumpian walls, but just walls. They don't keep anyone out except the robot. You can place numbers between 0 and 99 onto the board. You can place a letter here, whatever you want really. And then you have the left side pane that shows you the program, where you can write your program. And here is the debugging view. All of this was cobbled together last night in the stream and after the stream. And I think it's now at a point where I can actually extend this quite nicely. So let me just run this real quick. So what does this do? Yeah, it does a bunch of things. So I start this here and I put the number 3 here. Oh, yeah. So this is first calling a function forward until number, and it tells me which number it expects. So the number 3. The function is defined up here. Then it uses some built-in functions to turn the robot and move it around. Then it shows off the repeat statement, which is one of the control flow statements that there are. And yeah, this is repeated 4 times, and it prints, which is another built-in thing. And then it alerts people with a dialog box. So I think all of you have actually been in this stream, except Lotsakp or Yotsakp. Some of these functions are actually backed by JavaScript, like moving and turning the robot or scanning the number in the cell in front of the robot and so on and so forth. And it took me a while to figure out how to best do this because they need to be non-blocking. Because of JavaScript being single-threaded, but the script or the program that people write is blocking. So yeah, that was one of the technical challenges I'm going to talk about later. So let's execute this. I have 2 ways of executing it. Either I click run and it just does a thing. As expected, it does what it's supposed to do. And if I click debug, I can actually step through my program. I did not have time to implement breakpoints, but that is not a big task going forward with the infrastructure in place. So the editor highlights where you currently are. You can also see it in the call stack, and you can switch between the frames where it shows you the variables or locals inside that frame. Yeah, so this works pretty well. And oh, there's more people. Commander Root, Banananan, hello. I'm just showing off what I built yesterday and what I used in class today. I'm gonna start the postmortem in about 5 minutes. So yeah, the debugger works, the variable view works. There's of course some things that aren't super nice, like for example, sorry, the microphone keeps getting away from me. Sorry, that probably hurt your ears. There's of course a bunch of things that don't work so well just yet. So one of them is the error messages. In this case it's okay, but in other cases it's not so okay, like this. Again, part of the postmortem. Also, the debugger is a little silly because first step over this, you see the A, and it does this 4 times. Wait, let me do it only 1 time. So this uses lexical scoping, and the A should vanish from the debugging view once it is, but it doesn't because I do not track the scopes in the debugger yet, so that's a thing I need to do. But other than that, I'm pretty happy with how this turned out. So let me just quickly check on Twitch what it says in terms of view count, because I want people to see it all from the beginning. Oh, Erica is streaming. Okay, there's 4 people. The chat tells me there is 5 people, 6 people. It's a little... It's not a huge problem. Yeah, the robot cannot yet print walls, but adding that functionality takes like 2 minutes now, so that's very nice. It says 8 here. Oh, yeah, okay. Yeah, I think I'm gonna start with this post-mortem. So, let's go back to this. So my motivation for building... God damn it, let me fix this real quick. Oh, Daniel is here too. My motivation for building Paperbots. In the beginning of the year, I was approached by a friend of mine who is a teacher at the local Waldorf school. Waldorf is like an alternative type of school where people dance a lot and do Eurythmics and stuff like that. Not the band, but the thing, like dancing to express yourself and to heal yourself and stuff. And they're also into alternative medicine stuff, but the real benefit they have is they have a different kind of teaching method. It's very, Voldemort school, exactly. It's an interesting approach. They don't have the classical marks you get on tests or at the end of the semester, which has some pros and some cons. They approach teaching the material in a more hands-on way, in a more constructivist way, meaning they try to have the students think of real-world problems that they themselves tackle or want to tackle, and then give them the tools to do that. They also send their students to foreign countries for an amount of time to get a job there and work there, as far as I understood, and I think that's actually great. That's nothing the public schools in Austria would do. But as with any school, there's obviously some negative sides as well. Many parents of Waldorf kids don't like computers much, even though they themselves may work in software or in some IT-related field. So up until this semester, Waldorf school in Graz did not have any kind of IT courses, any kind of programming, any kind of computing, how to use your PC, blah, 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 things. Which is kind of weird, because I feel like this is like learning to write and doing math these days. And people assume that just because your kid has a phone and a tablet, it's gonna be super smart with that and be a digital native and I don't know, crazy shit. But the real truth is that phones and tablets are not creative machines. They're consumer machines. You don't create with your phone, except photos and maybe videos that you upload to whatever. And that's probably even less true for tablets, where you might do photos and videos, but I don't know anybody who runs around with a tablet in the real world. So yeah, it's a shame if your school doesn't teach kids how to use PCs, and I think it's even a bigger shame if they don't take the opportunity to teach kids how to do computing, which usually translates to programming, but computing is more than that. So that friend of mine, the teacher at Waldorf, approached me and said, "Hey Mario, we can. I would like you to hold a course this semester. It's an elective. The kids, we don't know how many kids will sign up for it, but it would be great if you could teach them programming in a semester." Yeah, and I said yes because I'm a fucking idiot and I don't know what saying yes to something like that means. I thought it should be an easy peasy thing. So that was in the beginning of the year, and then fast forward to September, like a week before school starts. I'm talking to my friend and say, "Is everything all right?" I created a lesson plan. I actually looked into CS Unplugged stuff. Computer Science Unplugged stuff is one area of research in the computer science education field. And I think if you want to teach computing, this is the best fucking resource there is. I don't know why this is not mentioned anywhere on sites like code.org or csunplug.com. These are educational resources and sites sponsored by the likes of Microsoft and Facebook and who knows what. And they're crap. They're complete and utter crap. This was the first CS Unplugged I stumbled upon. It was not super nice. Like, it's a mess. There's no real guidance. The topics are so and so. Again, sponsored by Google and Microsoft. So I was kind of let down by this. Then I also read Pepper's Mindstorms. Yeah, you read him with a P. So Seymour Papert was, or is, I don't know actually, a researcher in computing and computer education. And he's the guy who invented turtle graphics and logo and all of that stuff with his group at, I think, MIT it was. And there's a book from the 70s, no, 1980, called Mindstorms. And yes, that eventually turned into Lego Mindstorms. Some people from his group signed up with Lego and created Mindstorms with them in the later 80s, I think. And this guy has a fantastic grasp on what it means to teach computing, in my opinion. So I wanted to get away from this kind of bullshitty, look at us, we're big companies, we are teaching children how to learn. Yes, you're going to teach them that with a tablet and Sketch. Maybe that probably works for kids below 12, but as soon as you know how to write with a keyboard and use a mouse and turn on a computer, this is going to be limiting. And this is exactly the thing that the kids that I'm working with also told me. One of them actually had to use Sketch in the school he was before, and he was just like, this is not the real deal. This doesn't look anything like programming to me, and it seems very limited. So yeah, the problem is, 1 week before I started school, I was told there will be no computers. Because it's a Waldorf school, and they have a limited budget. I mean, the computers, the 12 they bought, they were supposed to be buying, cost about 1,200 euros because they got refurbished business machines. And yeah, they didn't buy them. I don't know, maybe out of spite, because they don't want computers there. Okay, I said I can try to do it without computers. So I was researching these kind of CS Unplugged things where you don't need a computer to teach computational thinking. And computational thinking, what is it essentially? It's building abstractions, decomposing your problem, finding patterns that you can reuse, and then eventually coming up with an algorithm to teach to solve your problem. This is computational thinking, and the important part is the algorithm, a repeatable set of instructions, or a set of instructions essentially, that you can apply to a specific set of problems. And getting that into kids' heads is very interesting, because there are some intuitive scenarios in their daily lives that kind of map to that. Like if you cook based on a recipe and stuff like that, but they never tried to structure it. So my initial plan was, because I didn't have computers and I wanted to get some extra time to organize some computers from some industry sponsors, my initial plan was I should do this just on paper. And I should teach them computational thinking. That is, taking a problem and not just fuzzy-wuzzy inspecting it and coming up with a sort of solution that's not formal in a way, but to actually think things through and get a feeling for what information do I need about my problem and how can I express the solution to this problem. And again, I looked through a bunch of shit. This is not the shit. Code.org and CS Unplugged, I don't feel are good resources, but those are the ones that will be rammed down your throat every time you ask for these kinds of resources. And eventually I found this. This is from Queen's University, I think. Queen Mary University of London. And there's one specific person that I'd like to highlight. I forgot his name. Well, just go on the site. And they have all kinds of amazing resources for unplugged. That means without computers, computing. So I went through these and picked the ones that I liked the most. For example, there's one called the locked in activity. And in the early 20th century, there was a French guy called Bobby, who was locked in, so he couldn't communicate, but he was fully aware. He could see, could hear, but couldn't talk or move, except for his eyelids. And the problem that you work through with the kids in this case is how would you write a book in such a state, assuming that you have a helper? And it's amazing because that kind of thing actually connects with the kids. And it's very easy to get them to, I mean, easy, nothing is easy, but it is easier to get them to buy into the thing you're trying to teach them if you have something that's tangible like that. So you go through this activity and you actually explore things like, okay, how can this person communicate with me? So we have to figure out a protocol. How can they communicate letters to me? Because communicating words is too hard, so let's break it down into a smaller piece. So that's decomposition. Then you figure, okay, maybe if you put all the letters on a paper and the helper points at it and the locked in person blinks, that's how I can communicate with that person. Then you have stuff like error correction. What is if I blinked at the wrong moment? You have stuff like, can I make it faster? Just going through 26 letters instead of that, splitting it up in two halves, and all of a sudden you have binary search instead of linear search and all of that. And it was very interesting playing this through with the kids. I didn't have to give much help or hints. They figured this out just because they had an intrinsic motivation to figure this out, because it was a problem that they could relate to in some form or another. And so they solved this. They even went through the full binary search thing on their own, which was mind-blowing to me. And they then even made the connection to the dictionaries in your phone, that you could use that. It's fantastic. So we did a bunch of these activities, but there's only so much computational thinking you can teach. So I was starting to look around for environments, coding environments, where I could teach them the basics of programming to solve their computational problems. And there is a bunch of different things. Obviously, the most well-known is Sketch. No, Scratch, sorry. Super well-known, so that's why I don't know the name. Scratch by MIT is a visual block programming thing. You've probably seen this. Yeah. You cobble together a bunch of blocks. It's very nice because you can't make any syntax errors, but it's also very limiting, and it's also very confusing because the bigger your program, your projects get, the less maintainable that stuff is. Also, the kids hate this. Like, starting from a certain age, they see this cutesy stuff and they're like, no way I'm gonna touch this. This is too cutesy for me. The kids I'm teaching are between 15 and 18, so this doesn't work. Okay, then you think, well, let's teach them something worthwhile, like web development. Okay. So, welcome to hell. You need all this fucking bullshit. And yes, you could just have them write a single HTML file, but even that is non-trivial. You have to explain to them HTML, then you have to have them walk through the hell of CSS, and then you push a language on them which doesn't help you at all with programming. JavaScript, it's not typed. And then you say, okay, we could maybe do TypeScript and maybe create like a limited environment, but still use all of that stuff. And you're like, no, I'd rather not. But still, there is some, how should I put it? There's some benefit in yeah, let's center a div, exactly. There's some benefit in having the solution for this programming environment for beginners be based on the web, because ultimately it might be able to allow you to share your work with others and remix it. And I think this is really important, and I'm talking about class today in a minute because kind of turned out that it's really important. Okay, so we scrapped that. Then the next thing is Python. So for Python, there's a bunch of options. You can use Visual Studio with it, and it has code completion. It's actually pretty good. I will probably switch to that later. There's also Tony, I think it's called, Yes, it's a Python IDE for beginners. It looks great on the surface, then I tried it out a little and it's super freaking limiting. It's like a corset. You can't set breakpoints, you can't do anything. And that's fine for the beginning, but I could not use this to get to more complex things. But let's assume we take Python. Now, the ratio from lines of code and concepts you need to understand to seeing something on the screen is huge, because there's only so many visual environments you can actually use in Python. So this is Pygame, which is like one of the more well-known things, and the documentation is just really bad. It's cobbled together things, and this is like the minimum amount of things you need to type to get something going. It's not terrible if you look at it from a lines of code perspective, but okay, now I need to know what lists are. Now I need to know that I need imports. Now I need to know, okay, there's modules and they have functions, and to call them the syntax is that, but then I also have objects like this, and they have methods, and what the fuck is going on? And just explaining all of this to see something on screen is really, really hard. Like really fucking hard. So I threw away Python, and as I said, it turned out we didn't have any PCs anyways, so I was done with the... Yeah, I considered Love2D as well. I just find Lua to be really not the nicest environment to be in. Also, there's not that many good development environments. The one I use for work is Zero Brain Studios. It's okay, but again, it's also a big, big, big pain in the butt to do this. So, where am I? Waldorf, CS Unplugged. What now? No PCs. That problem came up again because some of the kids didn't have PCs or laptops that they could bring with them. So even if I managed to get some industry sponsoring for this, I could not afford to buy 12 PCs or 12 laptops. And the school was refusing to buy any stuff to this day. Apparently that hinged on the fact that I was supposed to then maintain those machines forever for free for them. And I said, fuck that. Also, fun fact, none of the administrators of that school ever talked to me. I have no idea who is the CEO. I have no idea who is responsible for financials. I never signed a contract. The kids are under my supervision, but legally I am not responsible for the kids. If a kid dies during the lecture, not my fault, school fault. So yeah, schools are great. So I started with the CS Unplugged stuff, and then I figured, okay, we still have no computers. I cannot buy any computers. So I was looking into Raspberry Pi, and even that would cost me like $1,000 to get a setup where they could actually see something, because you can buy a Raspberry for $30, and you can buy a keyboard and a mouse for another $10, so you get $40. But then you also need a monitor, and the cheapest kind of thing you can find is $70, so now you're at $100 for a Raspberry Pi. And the refurbished computers that you can get in Graz at a special company, they cost about $100, including all of this. And they are full-blown Windows 10 machines, so yeah, what you're gonna do? But if I have Windows 10 machines, I need a space to lock them in, and the school sure as hell wouldn't give me that. So I figured, okay, until I have no fallback plan now, I have no computers, I still want to teach them some programming. So I came up with Paperbots. And Paperbots is inspired by things like Robocode or Swift Playgrounds or Code Combat. From Wolfgang's line, it was like Paperbots. I think it was first called Marvin, then Neptune, but it was a Java applet and no one supports them anymore. Yeah, so the fun part is my Paperbots actually has the thing in the name. Paperbots is played on a piece of paper. My initial idea was I can create a tiny language that is very easy to memorize, doesn't have a lot of keywords, doesn't have a lot of concepts, that you can then create programs in on a piece of paper. You write them down. Of course, there's a bunch of negatives to that. And you can actually practice programming during breaks when you're on the bus or public transit and so on and so forth. So this was the theory, right? And I thought, fuck it, I got no other options. Let's create this thing. So I sat down and created a series of quests to introduce some initial concepts like loops and variables and so on and so forth. Here you can see me execute one of the programs for the first quest. where you need to move this robot to the 0 here. So in this first quest, you learn that a program consists of statements, and there's different kinds of statements. And one of those statements is a function call. Where do functions come from and what are they? Well, functions are like little programs themselves that you can call in your program, which is great. They have a name, and to indicate to the executing machine that you want to call them, you have to put these parentheses there. This is called syntax. There is a lot of that in a programming language, and there's some level of familiarity with natural human languages and so on and so forth. And yeah, so I created this and thought I could do this for the next couple of units. And as you can see, there's problems with it. Like my fat fingers can't move the robot well. Keeping track of where you are is easy enough with this kind of method, but once you start having things like loops and nested loops or calling functions recursively, it gets really hard. So I said, fuck it, it's fine. The initial programs are really simple. So they would look something like... yeah, like this, for example, for the first quest, or a little harder quest. And then you have functions that get values, so you explain it, and then you have a quest and how to solve it, and the full program looks like this, and blah, 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 right? And I did this for one unit. I managed to explain functions that don't take any arguments and don't return anything, what a program is, what statements are, and that functions are statements. And I also, one of the kids who had previous knowledge, who did some Scratch, brought up repeat statements because he saw that this is getting tedious really fast. And that was great. So he could immediately transfer his previous knowledge to this kind of system, and the kids understood. But the kids also groaned because this was not programming to them. Obviously because there's no computers, right? You need a computer to program. That in the real world, you most often just sit there blankly staring at your screen while you think up the program you want to write, and then writing it down is just a mechanical thing that doesn't appear to anyone, really. So that was last week on Friday. And I had dabbled around creating a grammar for this with a grammar generator called PackJS, because I have another set of students, grown-ups, that I cannot meet face to face, but I still wanted to be able to share with them something. So I wrote a PackJS grammar. PackJS is a grammar generator for JavaScript, and I built a front end. And the front end was essentially, imagine this is gone, and imagine all you can do here is enter your code, and it gets syntax checked, and that's it. And over here, you have the same thing as here, so you can build your world. But if you click run, there would be a new set of buttons that let you execute the functions, like forward and blah, blah, and make the robot move. So you were still supposed to execute the program yourself, but you got at least some syntax highlighting and some error reporting if your syntax was broken when you wrote it here, right? And I did that with those bunch of adult students, friends of mine, over Discord, and it worked pretty well. But like with the paper version, it gets tedious very fast. You have the initial benefit of being able to edit your program real easily, while when you do that in on paper with pencil and rubber, you're gonna want to kill yourself because it's just terrible. So the paper version died because the kids wouldn't like it as much. Also, the effect of this little fucker moving is entirely removed from the paper version. And it turns out that that's actually really, really important to have this effect really early on, and seeing that what you wrote in your program has an effect in the real world, be it on screen or by moving a Raspberry Pi robot thing. So anyways, I had my paper version. I tried it on the kids. It worked, but it wasn't like enthusiastically received. I had this digital version where we would also have to manually trace through your program, which again was a hypothesis of mine, that manually tracing through your program will make you learn programming faster. Turns out that's exactly not the case. It doesn't matter if you do it manually or if you do it machine aided with a debugger. You just need some way to trace. But most of the time, you just want to execute your program, see what's happening without tracing through it, just to get this kick, this something moves, something happens, blah, blah. So that was a hypothesis that I disproved myself, working with the kids and working with my adult friends. So last Friday, after the Paperbot version was tested, oh yeah, that was actually 2 weeks ago, 2 weeks Friday, because last Friday there was no class. But 2 weeks ago on Friday, I tested the Paperbot version. In the week after that, I tested the digital version where you had still to manually execute your program. I decided 1 week ago, that was the Friday after those two things happened, okay, neither of these things involving manual tracing of your program work. There are no good programming environments. The school all of a sudden bought PCs. So great, I can now do digital stuff with the kids because we have PCs. That's another topic for later. I said, I got a week, Friday to Friday. Let's make this initial manual tracing thing a full-blown development environment with a programming language, a compiler for it, a virtual machine for the programming language, and some sort of visual representation that you can effect with your program. And that's what I did in the past week. You can look up what exactly that entailed on the streams. I'm just going to give you a quick rundown. So the first thing I built was the compiler. I used Pack.js to create the parser. From that parser, I then... compiler. From that parser, I then generated abstract syntax tree nodes. That was the next day, on Sunday, I think. On Monday, I created a type checker, which goes through the AST nodes and assigns types, because this language is a typed language, and checks that everything's valid. On Tuesday, I built a code emitter that would take those recursively constructed abstract syntax tree nodes and spit out a linear version of that for a virtual machine that I wrote on Wednesday. And the virtual machine has a very tiny instruction set, as you can see. It can push and pop stuff and string concatenate and do binary and unary operators. It can load and store variables. It can call functions defined by the user. It can call functions defined in JavaScript or TypeScript, and some jump instructions, so we can construct loops and if conditionals, and a return and a duplicate instruction to duplicate whatever is on the stack. So that was on Tuesday, the emitter, based on the type checked and type annotated AST. And on Wednesday, I built the virtual machine, and the virtual machine is the simplest fucking thing you can imagine. It just takes those linearized functions and has a loop or a step function that has call frames, and inside those call frames are slots for each local variable. Those within and outside of the scope, they are static, so to speak. They just don't get used outside of the scopes. And then you fetch for that frame the function's instruction list and take the frame's program counter, the index into the instructions, decode it, and essentially execute the effect. So a pop would pop a value from the stack, a push would push a value onto the stack, a dupe would duplicate the stack, store would load the stack's top into a variable's slot. Load is the reverse, so get the slot's value for the variable onto the stack. A jump, blah, 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 the calls and the external calls, which is a topic on its own. Yeah, so very fucking simple. And yesterday and parts of Wednesday, I built a debugger for this thing. So that required me to actually emit debugging information into my virtual machine output. So I know where the lines are and where things get defined and where the variables are. Like if I do this, var b equals 0, and then I have var res equals a plus b, and I debug my little program. I can step over things, oops. And I can click on those and you see they get highlighted. So all of this information needs to be there. I also need to know where my individual lines are based on the machine code. And let me show you a fun little thing. I also got a low-level debugging view, which I can enable here. Oh, and now you see the bytecode for, or the virtual machine code for this. So these are grouped by statements. Multiple statements can be on a single line, so that there's a differentiation in the debug information between the statement index and the line index. This I need for highlighting when I step over. And this I need to know how far I can step to execute one statement. Anyways, you can see this is very simple. I have two variables that get assigned to slots in the function. 0 is A, 1 is B, 2 is the result. I then have the push thing to push something on the stack, in this case a value of 0. That corresponds to this expression. I then have a store that takes that value from the stack and pushes it into the slot of the variable A. I do the same for B. Then I load the values from these two slots here and here, apply the plus operator, then store it back into the slot with index 2, which is variable res. And if I step over this, I don't have the instruction stepper, but I think I can do this. That's not found. Anyways, yeah. I also have a virtual machine instruction stepper. Okay, so that was 7 days of madness, and you can look that up. Yesterday I rewrote the entire UI and made it in components, and that leads me into the next thing. I took this from last night and then went into school this morning. This was the first time I saw the PCs that they actually bought. The school bought PCs in the end and let us into that room. Essentially it was supposed to be used by the typing class, so people would learn to type with 10 fingers and nothing else. Pretty interesting. Today I got there about half an hour before the class started because I did some other stuff before that. And the PCs had no internet. The PCs had no wireless LAN adapters. The PCs had no Ethernet ports. So I went to the nearest electronics shop and bought 12 dongles, Wi-Fi dongles, a Wi-Fi router, which I can plug a SIM card into so we can have internet, and then I bought one of those prepaid SIM cards. I also brought my projector, for which there is no table to put it on, so even with keystoning, the projected image is kind of skewed. But I managed to do all of that in the half an hour I had before the class was starting. And it worked. It fucking worked. The internet didn't work. And we had to set up hotspots so that the kids could connect to... Yes, that was my fallback plan. But I actually took the first 10 minutes to teach them a little bit about networks and what difference is between a local area network and how a local area network connects to the internet and what happens if you talk to a computer in a network, be it in a local one or the internet. So I also made them install drivers because a lot of them haven't done that before. I made them connect to different Wi-Fi SSIDs because some of them wouldn't work. But it only took like 15 minutes. And I think it's good to have them walk through these motions as well. I actually didn't unpack any of the USB dongles. I just gave them the sealed boxes and said, there, figure out how to use this. And if you don't know how to, ask me and we walk through it. And that was a pretty good thing. There's some core gamers in that group that can just take a PC, disassemble it, put it together, make it prettier and faster and whatnot. So that's cool. That helps with the team aspect of this whole endeavor. So then we were done with setting up all the computers, and I gave them this URL, and this was the program that they were seeing, and I told them to just play around with that. And there was a lot of oohs and ahs because they could immediately see that their code actually had a tangible effect. And this was the most important observation of mine. Paper-based systems, fuck that. It's not exciting. Sketch doesn't look like a programming environment. This also looks like a kindergarten kind of IDE, but it kind of has a more sophisticated feeling to it just because you have to type your fucking code. And while this is really terrible from a didactic standpoint, because now you're not only focusing on understanding a programming language, you're also focusing on not typing stupid characters that make the red box down there, which does not make any fucking sense to you as a non-programmer. While all of that is a negative, it actually is a positive, because it keeps you motivated, because it feels like you're doing the real thing. And that was a very interesting observation. So after the initial, oh, this is how it works, I just went through this whole UI with them. So here's where you enter your code, here's where you can start or debug your code. Then I showed them what debugging means. That was a very simple concept to understand, because we only debug programs like this. And I told them they can ignore this. It's really bad if you have to tell someone to ignore something, but in this case, I only had to tell them to ignore step into and the call stack, and I'm happy with that. It's hard to minimize this even farther. The names could be better, the visuals could be better. That's all I could do in 7 days. So this was very simple. And then the real aha or eureka moment was when I told them, okay, now click on one of these buttons, like wall, and just drag your mouse across. And as soon as this happened, it was like, hey, fuck, this is awesome. I can build my own game world. Amazing. So this is very important as well. If you give them something like, I don't know, this, yeah, you won't win any prizes with this. Obviously, this is fugly. This could be so much better and so much more entertaining and so much more interesting. And I think that's where Scratch actually has a benefit, because it allows you to build a scene that's mildly complex. But this was sufficient for today. For next week, the stakes are probably going to be higher. So we'll see how far we go. And today we managed, through the power of this little thing I built over 7 days, to go through functions with parameters and expressions, like for example, hey, anywhere where there can be a number, you can write an arbitrary expression and it follows the rules that you know from math. It's great. The computer is good at math, so you can write this anywhere where there's a number, because what the computer is gonna do, yeah, it needs a lot of flashy stuff, I agree. But they weren't bothered by this. Like, just the fact alone that you can build your own maze was already good enough to keep them entertained. Because even if they didn't listen to me, like some of them wouldn't, obviously, because they're kids. We were kids. We wouldn't listen to our fucking teachers. They at least had something to stay inside of this environment, just by drawing, I don't know, a penis or boobs or whatever. I don't care. Or building the most complicated maze. And that's cool. Because eventually, when you're done building a maze, you now want this little fucker to move around with it. So you are sort of forced to start being interested in this side of things. And I have not had one student who was not interested in this side of things. And I had a bunch of students who would stay after class was over and finish their programs or make them a little bit more complicated. And one takeaway was that all of them ask, how can I save my work? And currently you cannot, except for copying this and then rebuilding this. So this is probably something I'm going to build until next week, but that only takes like a minute. I can store it in local store and then have a download button that gives a JSON file that they can take home with them, and then a load button where they can specify the JSON file again. So anyways, yeah. Because all of this is actually serializable through JSON. I took great care in that because, yeah, I want this to be better than it is now. So what were my takeaways? You need something to keep them entertained even if they don't listen to you. Give them a tool where they can build stuff without knowing how to program while you talk at them. While you try to get across that if you don't listen to me, you're not gonna make this fucker move. Yeah, emojis. I think you could actually enter an emoji here. I don't quite know. Emoji. I don't know how to type emojis on the keyboard, so see if we can get this inside there. Okay. Yeah. Unicode is fun. So takeaway, give them something to work with if they don't want to listen to you. And make it so that they are motivated to eventually be interested in this left-hand side, where they need to know what this means to make the whole fucking world work. It's really important. If you don't have that like this, yeah, you can quit. Because when they see this, the first thing they're gonna do is, hello, Instagram, or whatever. Hello, YouTube. Hello, Twitch. Hello, whatever. But if you give them this and make it mildly entertaining, you at least got their attention in some form. And that was important, I think. I'm not saying that it works all the time. Well, they eventually connected to hotspots with their phones, so they did have internet later. Obviously, their hotspots suck because their bandwidth and data plan doesn't allow for streaming cool stuff, so that helped. Okay, the other takeaway, this was not important. Nobody traced their program with this. They would just write it out and then run it. And that was it. Oh, that was interesting. What happened there? Ah, it printed null. Cool, because the number is not. Yeah. There was also another part to this. I gave them the definitions of functions that were available to them. So I would give them something like this. But I would also give them something like this. And this language is a type language. So you specify a type for your parameters, and for local variables, you can optionally specify a type, but it's very easy to infer that from the type of the expression on this side. So this is a shorthand, and I'm going to teach them that. And I was very surprised that this did not take them a long time to understand. And also why the specification is written like this, but when you use it in your program, you write this. I had a feeling they managed to grasp that real quick. And then there's another function, which is defined like this. And this took a little longer, because explaining expressions and explaining return values and how you can use them to do something is a hard concept, turns out. But eventually we managed to figure that out as well, and we managed to figure out the repeat statement as well, and blocks of statements, and all of that is cool. So I'm very happy with how this turned out. It was 7 days of hell because I would work during the day, and at night I would stream my bullshit madness. And on the technical side, the takeaways are, don't write yourself into a corner. I managed to not do that, apart from how I set up the UI initially. Going forward, what's the plan? The plan is to make this prettier. Step one. So I have asked for these services, the paid services, because you should pay your artists. The paid services for Eve Sampix, and you should follow him on Twitter. He made my avatar, and he's really good. He mostly works in pixel art, and I like what he's doing. And he said, yeah, he would help me out with this for monies, because that's how you do stuff. If you do something for somebody else and it's work, you ask for monies. So I'm gonna pretty this up and make this world a little bit more interesting. The other plan is to add the bells and whistles that a development environment needs. So the error messages are terrible. And this is because the parser I'm using is generated. For having all in one place, you could serve Paperbots from I could. And that is essentially what I did in the end, just without the Raspberry. So next plan, fix up the stupid error messages. That means I have to write my own parser, because you can only have nice messages if you have your own parser. It's not hard, because I constructed the syntax of this language in a way that a recursive descent parser is really easy to write. So that's gonna be a big task, but I can postpone this, because so far, if there's red down there and squiggly red up here, then you just ask Mario what's up. And that's fine with me. Yeah, breakpoints, really important. They shouldn't be hard to implement. I just haven't implemented them. The scoping of variables in the display here, that needs to work, because otherwise that's really terrible. Oh yeah, I shouldn't have done that. So debug, step over, A is now live, and A is still live, and that should not, because that's super fucking confusing. The representation of this should be better. You should also be able to edit values here. And then there's a bunch of language features that need implementing. Like I do parse and construct data for records. But currently I cannot really interact with that because I cannot instantiate or create a value of type point. That is like probably 20 minutes of work, and that's an amount of work that I would like to stream in the future. So if you want to keep with me here on Twitch, you can prepare for topics like how do I implement records in a language with a virtual machine. Another thing I need to do is lists. We need some composite data structures that are variable in length. So there will be a generic list type. The language ultimately will be what I did with we, this other language project I had. This is gonna get merged. I now have this and I'm gonna make this the full we. But baby steps. So I need lists, and I haven't even figured out syntax for how to create lists and how to specify the type yet, and blah blah. What the language currently has is it knows, I don't know, it knows how to overload functions, which is really nice if you don't have generics. So I can say a string list of, yeah, I don't know. I'm more about this bike shed. Something like this, and then you have a var L list. I don't know. And if you want to specify the type, it could be something like list number. It needs to be easy to type, easy to remember, and consistent. If I construct a list like this, the type specifier shouldn't look like, I don't know, like this. This is just nasty. Yeah, something like this is missing. So that there's quite a bunch of work on the language side that needs to be done. Thankfully, I got a lot of stuff done already with the overloading. That's great. So that's one part of the thing, the language. The other part is this virtual machine. If you look at it, obviously it's slow. It's a lot less slow than I expected though, because the individual virtual machine instructions and the code I emit are very compact. Since the virtual machine is run in JavaScript and JavaScript is not typed, I can actually do away with a bunch of stuff. Like in a virtual machine written in C, pushing a value of arbitrary type onto a stack might not be as nice as this. Here I can just take a number, a boolean, a string, a JavaScript object, and push it into an array. That's my stack. Also, as I said, the complexity of the instruction set is very low, and I can easily apply optimizations. Like if I look in the... I run a VM in a VM, yes, but the VM is JIT compiled that runs the VM. Or the code in the JavaScript VM is JIT compiled. And it turns out you can write pretty fucking fast interpreters even in a JIT compiled environment. Ultimately, I want to emit to WebAssembly. But that is a bigger task again, because then I need to do stuff like garbage collection on my own and blah, 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 blah. For the games and the environments I plan on doing, this will be fine for quite a long time. So that's the language side and the virtual machine side. And then we have this here. So this is nice to start out with. But eventually I want them to be able to have a canvas where they can freely draw to, where they can get input from the user, be it touch or mouse or keyboard, where they can play sounds and music. So the whole thing, right? And the fun part is, needs enemies. Yeah, it needs enemies, right? The fun part is this component here, right, is hooked up to the virtual machine, so that calls like forward actually make the robot go. And I wrote this thing in such a way that hooking up a different kind of environment, like imagine an HTML5 canvas and some functions that you can call to draw on that or load an image. Yeah, libgd Paperbot, exactly. It's very easy to do this now because my component system allows me to do something like this. So the forward function that you can call in the code here is defined as an external function to the virtual machine in the compiler. And it has a name and it has 0 parameters and it returns nothing, but it is asynchronous. That is, when it gets executed here in my virtual machine needs to give back control to the JavaScript virtual machine because JavaScript is single-threaded, and the little robot should then just move its butt. Wait, expected, yeah, it doesn't like that. So the little robot needs to move its butt, and this butt moving is asynchronous to my program. But my program needs to wait until this butt moving here in the UI thread is done. So my external functions can be blocking or asynchronous, which is really fucking important. Since I have this mechanism in place now, writing a new function just consists of me adding this. Like I could have a function that, I don't know, what could I do? I could have a function that says log to the console, right? And it takes a new compiler external blah blah blah, which has a name, which is just a text, and it has a type, which is string, and that maps to the internal type of in the virtual machine. It returns nothing. Is it asynchronous? Nah, because we don't need to wait for this to stop. It is instantaneous if I log to the JavaScript console. And then I just need my function. And my function takes this text thing, and then I just say console log. Yeah, the text, exactly. And then I also need to run this locally because otherwise nothing gets done. And I can't quit my fucking workspace. So I just exposed the function to my script. It does something in JavaScript. So now I can call this and say log, come on, don't be so stupid. Log hello world. And I can run this, but I will need to see the console output. So I'm gonna push this back into my thingamajig here, go to console, and then I run this. And here's my hello world. And that's how freaking easy it is to hook up JavaScript stuff to this environment. So you can imagine I can build a component where the component exposes a bunch of callbacks or functions that can be called synchronously, like draw me a line or load me an image. And this component can say, okay, dear virtual machine, I'm loading an image when you call this function, so I'm asynchronous. Just don't execute anything until I tell you I'm done with this asynchronous call. And it's great because the people writing this here can just write a linear program. Like I could have something like this and say load image and then give it a URL, I don't know, HTTP lab.io image.png, and their program would stall for as long as it takes for the background processes to load that image, and they don't need to do any callbacks like they would have done in JavaScript or TypeScript. And then they can just say draw image. And all I need to do is expose these functions from a new component that I write over here. And that is limitless. I can do whatever the hell I want. I can create components that are better, an extension of this, like you can have multiple robots, and I can have a canvas where you can build your own games with drawing lines and images and getting input from the keyboard and the mouse and so on and so forth. I can build a 3D environment here with WebGL where they can do 3D stuff in this little script thing. And people outside of my brain can also create their own components and hook them up with this virtual machine, because honestly, this is all the code you need. It doesn't even matter how you create your component and how you put it into the thing. All you need to do is you send an event through an event bus that says, hey, here's a bunch of external functions. When you compile the script, please take them into account. And when you execute the virtual machine, please also take them into account because they are JavaScript functions that you can call. So it's very, 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 very easy to build a new component here. And in terms of the tactics and educational things, you could imagine that you have a course where you start out with something simple like this, and then you build components that are more complex and do more stuff. And you expose more JavaScript functions in here while keeping them synchronous or blocking in this language, which makes reasoning a lot easier. And there's also a lot less code. Yeah, so lots of language work, this virtual machine parts. Yeah, that's the point. Now you can do that. It's really easy. Like, it's really super easy. If you look at how this is done, this is the application class, so to speak, and I have these components. I have the editor, which is responsible for compiling this and checking if there's an error. I have the debugger, which is this component, which manages the buttons, and when you click run, it sends messages to everybody else. So this, for example, would then know, okay, I now need to go into simulation mode. This doesn't do anything apart from disabling text input while this is running and so on. But this doesn't need to know about these people. So it's classic event bus stuff. So compositing those components is super easy. You just build, this is my whole application now. And this is how I wire things up. I just decide that I put all of these on the event bus. They can send themselves each other events. Then I build my HTML and decide how I want to lay out those components. And they will render themselves. They have a render method which returns HTML component or element that you can plug anywhere into your freaking DOM. And that's it. That's all there is. You could just take out the playground here and put in your own thing. Then when the render method is called, you know your component is now being initialized in that render method. All you need to do is to send these external functions via the event bus to anybody who's interested, which would be the compiler or the debugger. So this is very nice. Oh, cool. See ya, Igor. So yeah, the plan going forward, make the language better, make the debugger and virtual machine faster and more capable, and build more components. And for my final trick, I give you blank space. This area down here is gonna be really important. Anyone remember the QBasic help system? This is where you're supposed to type in the chat. Yes, yes, Mario, I know the QBasic help system. So QBasic had a fantastic help system for its time. Not only could you just click on a token in your source code and go to the help. Yeah, add space, exactly. Go to the help of that token, whatever it was. But it also had a orientation, a general usage reference of the UI and of the language and blah, blah, and a quick reference with all the functions that QBasic would give you and so on and so forth. So this down here should become the documentation / teaching window. And since we are using a browser, we can not only have text, we can have animated images, we can embed YouTube videos that show you how to use the UI, and so on and so forth. And that's really fucking powerful. Because not only can I show you documentation about your own program, like listing all your functions and maybe the documentation you write on your own by doing the classic Java doc, whatever thing. I can show you what this component exposes in terms of functions and give you definitions for those and verbal written descriptions of what to expect. For example, this print function only takes numbers 0 to 99 and otherwise shows an alert. That's important to know, but that's not something you can encode in your programming language here. So, and then I can give them a general reference for all the functions that are available. I can give them a reference to the language itself, and they can click here, and here I will show whatever is most important when you click on this thingy here. So this area is gonna get a little bigger, while this gets a little smaller, and this probably also gets a little smaller. And it's gonna contain a lot of stuff that will help you learn programming yourself. And who knows, in the future, this little area could also have a little chat box where you can collaborate with other people on the same thing. That would be my plan. Just make the language a little better, make the UI prettier with the help of Eve, create more components that are more powerful, that allow you to do more than just move a robot around, but for example, build your own games, and have documentation that is interactive, that is digital, that's not just words, that is also videos and whatever other learning material you can imagine that you can put in a browser. So yeah, I'm gonna continue working on this. Yes, it is decoupled from the views. It just sends an event through the bus that says, I stepped, here's the line I went into. I can show you the code for that. It's pretty simple. So the debugger, here's the entire debugger. So if you click, where's my click handlers? Yeah, so you have two buttons, run and debug. They will create the virtual machine and then say to everybody, I'm about to run the program, or I'm about to debug the program. And then when you click on step over or step into, all I'm doing is saying, hey motherfuckers, I'm going to step to this line of code. You better, or I stepped to this line of code. You better update yourself. So again, it's very simple. And if you have a component that wants to do something with that kind of information, sure, just listen for the event and processes and update your thing. So yeah, that is the plan. So I would appreciate help. The code base is on Google, no, on GitHub's, which is now Microsoft. It's in here. This is the first npm project I ever did, so it's probably broken in all kinds of funny ways. Thankfully, the packaging is really tiny. I'm old school. When I do a distribution, I just do this myself in a script. I don't use any fancy pants stuff. Yeah. And I could need help with, I mean, if you want to work on a language or virtual machine debugger stuff, that would be great, but I could also need help with new components here. And it should be, again, very easy to create that. I would probably just give you a way to instantiate this, and not only give it a parent, but give it a list of, I call them widgets. They can render themselves and can react to events. So you put in your widgets here, and the Paperbots app will put your widget where it belongs. And then you only need to have an HTML file that does what you need. In this case, I have the style in here, but this is the entire HTML because the components render themselves. Yeah, that is pretty much it. I am super proud of being able to fix this up in 7 days. I haven't felt this good about a thing in a long time. Yeah, the README for the paper version, that took, I don't know, a bunch of nights, 7 nights or so. 1 quest per night, something like that. So, and a night is 2 hours in this case. This is also interesting, how much code maybe was written in 7 days. It's a terrible metric anyways. But traffic, no, commits. The commits are not what I want. Does it tell me codes? No. Pulse? No. I don't know where the fuck I can get code frequency. No. Maybe. Ah, contributors. That's where I get the data. Yeah, so I've written a total... Okay, that is a problem because I also commit the TypeScript, JavaScript output and the source maps. I do this because then I can run it without needing the toolchain locally. It's a stupid thing, but I would gather how much code can there be. Do I have this installed? Oh no. So how does this work again? PC minus L. Is it directory? PC clock. Let's see. I'm pretty sure macOS doesn't have Xargs. Yeah, that worked brilliantly. Oh, not PHP, but TypeScript. That doesn't sound right. Oh, it also fucking, oh my god. Yeah, so that was about 7,000 lines of code in 7 days. I consider this a win. Although I have to say that the parser is auto-generated, so 4,200 lines of that come from my grammar and the generator creating that many lines of TypeScript code out of a grammar that's like, where we are, out of a grammar that is about 450 lines of code. And the grammar is really easy to follow, I think. So it takes the input and then recursively parses it and generates those AST nodes. For example, for, I don't know, for a while statement, it says I have an AST node, it's a while, and it has a condition, which itself is an expression, which is a recursive subtree of this AST, and then it has a block, which is a list of statements, which themselves are AST nodes, and blah, blah, and then it has a location for error, highlighting and stuff. So yeah, so I would say I can take this number and say this is only 450. So I wrote about 860 plus 247 plus 450 plus 1484 184. I didn't turn on the lights, so I don't know what I'm doing. 153. So about 3,000 lines of code in total for a compiler, a type checker, a debugger, virtual machine, the virtual machine emission, and this ugly fucking front end. And I'm very happy with this. It was a very terrible week, and I will stop streaming that often now and that long. I just figured since I have to put in the time, it gives me some rhythm also streaming. Plus I'm gonna get Twitch affiliate, so now I get all the beer monies, the whole 10 cent per year. Yeah, and I can at least document the work in some way for future people who stumble upon the problem of building a statically compiled virtual machine interpreted programming language with a debugger. You could take the code as it is now and build your own thing. Cool. There were a couple of people who joined me every freaking day, so I would like to thank Chronosella, who's been with me through all those 7 terrible nights. And Commander Root was also here a lot, as I remember. Igor was here a lot, so thanks people, even though you don't talk a lot in the chat, which is probably because you're amazed by me talking so much. Thanks, it's nice not being alone while doing this kind of work. And I hope I could give you some insight into how compilers and virtual machines and debuggers work and how you wire all of this stupid stuff up. And yeah, maybe you want to contribute to this and help me build stuff. I'm not a god among men. I just have no life. Well, I didn't for the past 7 days, but I'm going back to life now. Know your computer science, then this shit is easy. And you don't need to go to university to learn your computer science. Yeah, so contributions welcome, feedback welcome, comments welcome. If somebody locally wants to sit and have a beer or a coffee and talk about this, no problem. Just hit me up. And yeah, first of all, it's live, like this. Coming from a person like me is perfect because I'm the most typo producing person in the world, I think. Anyways, thanks everybody for watching. I'm gonna have maybe a stream a week or every 2 weeks now going forward, just showing off how I implement a feature. So the next stream's probably gonna be how do I implement records. If you're interested, like and subscribe. And I don't know what the fuck else you can do. Follow, I guess, so you get a notification. Bye, pretties.